Okay, we're going to talk about graphing with transformations. And so we're going to look at some quadratics written in vertex form, but where they also might have a horizontal stretch or compression. So let me give us an equation here. Okay, so let's say that we had this equation here. The first thing that we want to look at is we want to make sure that what's inside the function, so the stuff that's inside of what's being squared, is written so that we can see the x minus h group, which means if there is a b value, a coefficient of x, we want to factor that out. And when I say factor it out, I don't mean out of the squared part, but just that we're rewriting it in this format inside of the squared. So in this case, I would take the 2, I would take the 2 out of 2x plus 4, leaving me with 2 times x plus 2. And then I'm going to set up my tables, and then we'll also talk about how to verbally describe the transformations. So remember, for a quadratic, this is the parent function that we use. Just the numbers right around 0 being squared. And then we just want to transform those values separately, what's happening to the horizontal values and what's happening to the vertical values. So for the horizontal values, that's everything inside of the function here, inside of the squared. And remember, we've seen a couple examples of how these things act, and though there's a 2 inside here multiplying x in the function, on the graph it doesn't measure like things have been multiplied by 2. Instead, the x values have reached y values at double the time, kind of speeds up the time, but that means it lowers the distance on the graph. So we actually use the reciprocal of 2. We use 1/2 to multiply the x. And remember that this other quantity here is x minus h. So even though it says x plus 2, the h value there, if it comes from the formula x minus h, would be a negative 2. And then our vertical transformations are the things that are outside of the function, the things that are happening after the squaring is done. So we see a negative 1/3 multiplying our y and a minus 1. Okay. So before I go through the chart and write these down, I just want to go through what I would say about these verbally. So when we look at the horizontal ones, we have x being multiplied by 1/2. Whenever you're multiplying by a number, you're talking about stretches or compressions, and you just need to think about what multiplying by that number does. So when I multiply something by 1/2, it makes the value smaller, which would be a compression. So in both cases here, multiplying by 1/2 and multiplying by 1/3 makes them smaller. So we have 2 compressions. One's vertical because it's happening to y values, and one's horizontal because it's happening to x values. So we're going to list a horizontal compression by 1/2, and we're going to list a vertical compression by 1/3. We're also multiplying the y values by a negative. Multiplying by a negative is simply changing the sign, which is going to move points to different quadrants, either left and right if you're changing the sign of x values, or up and down if you're changing the sign of y values. So when you multiply by a negative and you change the sign of one of the coordinates, the transformation type that you're using is a reflection. And then you want to tell me which axis that's over. And if you think quickly about changing the sign of y, above the x-axis is where all the positive y values exist, and below the x-axis is the negative. So if the sign was changed of just the y coordinate, if it was below the axis, it would switch to being above the axis. If it was above, it would switch to below. And when you do that, even though you're changing the y coordinate, you're actually flipping things over the x-axis. That's kind of the boundary between those negatives and positives. So this would be a reflection over the x-axis. The values then that are being added and subtracted, like the -2 from x and the -1 from y, are like subtracting 2 on the number line or subtracting 1 on the number line. So when it's happening to x and we're subtracting 2, that's a shift 2 units to the left. And when we see that -1, but it's happening to y, that's a shift of 1 down. So those are how we would verbally describe the transformations. Then we would go ahead and actually transform the values. So I'm going to take every x value that was part of my parent function and do just the horizontal transformations to it. So I'm going to multiply everything by 1/2 and subtract 2 and get a new list of x distances. It's how these distances would be changed by the transformations in this problem. So I'm just listing those. And then I'm going to go through and do the same thing to the y values and just perform on the y values each transformation that's happening vertically. Let's see. So this would be -4/3 minus 1. It's -7/3, -2 1/3. And then for 1, I have -1/3 minus 1. It's -4/3, or -1 1/3. For 0, I have -1. And similar values here. And then I would place those values on a graph. So I would give myself an x and y axis and plot these things, make sure it looks like the parabola, and make sure I see the turning point as the HK, the vertex, which at the parent was 0, 0, but now should be at -2, -1. So then -2 1/2, -1 1/3, -1 1/2, -1 1/3, -1, -2 1/3, -3, -2 1/3, and I can see the graph of my parabola here. Okay. So in addition to knowing the transformations and being able to get new points by them and list them, we also want to make sure that we can give the characteristics of the graph. So if you have follow-up questions on that, let me know.